What's going on, Math Rockstars? What we're going to be looking at right now is how to solve one-step equations. Why do we call them one-step equations? Because it only takes one step to figure out the solution. But if you look at what we have here in front of you, we have 1, 2, 3, 4 steps. And I know what you're thinking. You're probably thinking, wait, 1 step, 4 steps? That doesn't make sense. Guys, it doesn't matter what kind of an equation you have. Whenever you have an equation, you're solving it, you can always follow these 4 steps, even when it gets more complicated, which might happen later down the line as you get into future math courses. But every time you see an equation, I want you to think of these 4 steps. So, what is an equation? An equation is a mathematical statement that has an equal sign. If you see an equal sign, what I want you to think back in the back of your mind is these 4 steps every single time. Looking at what we have here, we're going to be filling in some keywords as we're working, and in each of these blanks, we're going to be using one of these 6 words. Sometimes it might be a little bit different, but I want you to think about these 6 words here in front of us. We're going to go through them one by one. Inverse. When we're talking about inverse, we're specifically talking about inverse operations. We talked about that earlier. Just as a reminder, the inverse of addition is subtraction. And that goes both ways. The inverse of subtraction is addition. And the inverse of multiplication is division. Again, those go both ways as well. So at some point, we're going to be using that word inverse. Check. Solution. Equation. Identify and isolate. And this word gives students a hard time. When we're talking about the word isolate, ladies and gentlemen, that means we're trying to get something by itself, to get it alone. So that's your overall goal when you're solving equations. What I would like you guys to do is read these 4 steps to yourself. And as you're reading them, I want you to think, okay, where do these 6 words belong? Are you going to be using more than once? Where do they fall in the correct order? Because they're mixed up here. So take a couple seconds and read those over to yourself. Now that you've read it over, let's go ahead and take a look at a couple of examples. Let's take a look here at example 1. We have x plus 4 equals negative 2. Now what's really important in mathematics, ladies and gentlemen, is don't just start jumping into the problem and becoming a robot. What you want to do is take a step back and think to yourself, well, what kind of a question do we have here? And that's important, especially when things get more complicated and you learn a lot of material. You don't want to be rushing what you're doing here, especially mathematics. You want to take a step back and think about what's going on. So I look at example 1 and I read it out loud to myself, and it says x plus 4 equals negative 2. This, ladies and gentlemen, in the back of my mind is, I know it's an equation because I see this equal sign. And every single time, no matter what, whenever you have an equal sign, you want to separate the left side from the right side. And there's a lot of different ways you can do it. I like to use a lazy river, just like this. So, we have an equation. What do we do first? First, I would identify the variable. How do we identify a variable? Well, a lot of students just want to point to it, but on your work here, every single time, ladies and gentlemen, we want to circle the variable. So I look at my equation here. I found the variable x right here, so I'm going to circle the variable. That's step number 1, because you want to figure out, okay, that's what we're looking for, and that's what you're trying to solve for. So looking at x, what do we do from here? Step 2. Next, I would use inverse operations to isolate the variable. Your overall goal, ladies and gentlemen, is to figure out what is x. Right now, I'm looking at this example, number 1, and I realize that, hey, x is not by itself. I need to get it by itself. I see some numbers here on the left-hand side, so what do? What I want you guys to think about for this next step is a magic pen. Now, I know you guys don't have a magic pen, but I want you guys to just think about this step. So I'm going to take out my magic pen here, and I'm going to really focus in on x. Right now, if you look carefully, this is what you want. You want to have x by itself equal to some number. But you don't have it by itself right now. There's something else that's around it. So if I look carefully at x, I need to figure out, well, what's happening to x? Right now, in this example, x is not by itself. X is being added by 4. One more time, look carefully, look at x. X is being added by 4. So what we need to do is write that down off to the side. This is a very important step, ladies and gentlemen, because from there, once you know what's happening, you can figure out the inverses and get x by itself. So I'm going to write that down off to the side here. So I know we're going to be using inverse operations here to undo add 4. So I'm thinking to myself, okay, well, if you're adding something by 4, to get back to where you started or to what you want, you would have to subtract. Because the inverse of addition is subtraction. But more specifically, what are we going to subtract? Well, if we add 4, it makes sense that we're going to be subtracting 4. So whenever you're figuring this out, ladies and gentlemen, I like to put a little bubble around it. And what you need to pay attention to is we're going to be doing what's on the right-hand side here. We're always going to put the inverses over here. But let's use complete sentences. I would subtract 4 on both sides of the equation to create a zero pair. And you're probably wondering, wait, what? What's going on here? Well, let's look at this example. Since x is being added by 4, we're trying to get x alone and by itself. To isolate it, we need to subtract 4 on both sides of the equation. And it's important to know what you're doing and why you're doing it. So take a close look here. Okay, x was being added by 4. To get x alone, we should subtract 4 on both sides of the equation. But look carefully here. You have a positive 4, you have a negative 4. That makes, in fact, a zero pair. That's going to go away. And we have x by itself. And what do we have on the left side? Well, it's just x and 0, so let's just write x. And we have negative 2 and negative 4, negative 2 minus 4. So here, guys, because we are adding and subtracting, you want to imagine a picture. We have 2 negatives, we have 4 more negatives. That's going to give us a total of negative 6. And many students think, oh, cool, we're done, we can move on to the next one. Not necessarily, because you might have made a mistake here, and you're better than that. You're better than that. The nice thing about equations is you'll know if you're right or if you're wrong if you do this very last step. And this is what I'm expecting you guys to do every single time. No exceptions. Finally, once I found the solution, I would check the solution to make sure it makes the equation true. This, ladies and gentlemen, negative 6. You're saying that x has to be negative 6. Well, you need to prove it. If we take negative 6 and we plug it back into our original equation, we should get a true statement. When we're checking our work, it's very important to always write down the word check. When you're checking your work, you always want to check the original equation because this is what you started with. We might have made a mistake at some point, but this is what you want to look at. When you're checking your work, before we plug in negative 6, we're going to replace x with parentheses. Why are we doing that? Because it just keeps our work organized, and you'll see why later on when we get to more examples that are a little bit more complicated, like two-step equations. Now that you replace x with parentheses, we're going to take negative 6 and plug it in or substitute it. Now be honest with yourself, okay? Don't try to force the check to work out. Here, ladies and gentlemen, what you need to do is make sure that the left side is the exact same as the right-hand side. So what you need to do is make sure you look at the left side separate from the right side. So taking a look here, I have negative 6 plus 4. Okay, negative 6, that's 6 negatives. You have 4 positives. That's going to give us negative 2. So what we're hoping for is we know we're right if on the other side, on the right side, we have negative 2 as well. And what do you notice? Here, OMG, ladies and gentlemen, negative 2 equals negative 2. This is a true statement. Negative 2 is always equal to negative 2. Check. It works. We got the right answer. So let's just refresh our memory of exactly what we did. Looking back at our work here. First, I would identify the variable. Here we identify the variable by circling x. Next, I would use inverse operations to isolate the variable. That was this step over here, ladies and gentlemen, where we looked at x with our magic pen and figured out what's happening to it. Well, x is not by itself. We were adding 4 to x. That's right here. So to undo adding by 4, we would subtract 4 on both sides. Step 3, but specifically, I would subtract 4 on both sides of the equation to create a 0 pair. Finally, once I found my solution, I would check my solution. So after we did our work here in step number 3, we found out our answer was x equals -6. But don't stop there. We need to check our answer. We copied down the original equation. We substituted or replaced x with parentheses. Then we plugged in -6 and showed that the left side is the same thing on the right-hand side, and we got our answer. So I know this might seem like a lot of work, ladies and gentlemen, but if you follow these steps, you're taking your time, you're nice and neat, you're going to get the answer every single time. And this is very helpful for when we get into more complicated equations. Last step, ladies and gentlemen, is make sure you're always checking your answer. Always, always, always. That way you know you're doing the question correctly. There's oftentimes in mathematics where you're doing a question and it's not easy to see whether you got the answer correct or not. But here you'll be able to figure it out. And that's all. So, thank you for watching.